Hi, and thank you for tuning in for NetRel episode 2. This will be a twofold series. In this episode, we'll talk and show you the Yang browser that my colleague and I built for the srlinux-yang models. So in this particular series, I will show you what we built into this Yang browser, what it can do, why it is important to have one, and which questions can be answered by having a Yang browser like we did for srlinux. In this subsequent series, we will discuss how we built it, specifically which tools did we use and what plugins we used for different open source tooling that allowed us to create this nice Yang browser that I'm going to show you. And the good part is that we only used open source software to build that one. So it's a perfect solution. It costs nothing. We didn't use any paid software, and it answers all the questions that we pose to our Yang models. Sounds interesting? Let's go. The srlinux-yang browser is actually something you launch in a browser. The address for the Yang browser that we are talking about is yang.srlinux.dev. And as you can see, the starting page is pretty minimal. We do not have, all the Nokia products listed here, advertising, selling parts for Nokia 3310. It's just the srlinux-yang models per release and a short explanation what this browser can do. We specifically wanted this to be a simple website so that you as a user do not need to run anything on your machine or in the data center that you have in order to browse the Yang models. Instead, we did all the heavy lifting for you. So all the models are ready to be consumed, and you just, type the URL in your browser and dive straight to the models. All right, enough talking. Let's see what we have inside of each of those releases. So I will open the latest and greatest 21.11.1 release, and that will land you on the main page of the Yang model browser. And as you can see, it is a bit different, right? Typically, people think of the Yang browser as the tree navigation structure, like the output of a PyYang, for example. On the other hand, we decided that the most important piece of the Yang browser is actually the search tool through the Yang paths. So think about that. When you need to work with any model-driven interface, be it netconf, GNMI, and of course, regardless of the network operating system that you work with, the way you interact with the model-driven network operating system is that you constantly refer back to the Yang model. The model-driven interface, hence the name, is modeled, and typically it is modeled with Yang. So whenever you want to find a leaf to extract for your telemetry application, or you want to know how do I configure something, you need to know how to access this particular leaf in the very big model that your NOS uses. What you are currently looking at is the main page of the DIY Yang browser for the srlinux 21.11. And as you can see, there is the path browser that occupies the main space of this page. Now, what this path browser is, it is essentially a search tool that will allow you to filter through the paths that your Yang model consists of. Now, have a look at this table. It is actually all the paths that srlinux-yang model has. Actually, 4,800 paths that this model has, both config and state. And they are represented here as the flat condensed paths from the very top of the model to its very bottom. So how do you use this path browser? For example, we take a case where you launch a srlinux container or any other network operating system for which you build something like that, and you want to know how do you access a certain leaf. Like a typical hello world kind of example would be getting the version of the operating system. And although this might sound like a trivial case, it's actually not. Because how do you know where the version number leaf is located in the potentially very big tree of paths? You can, of course, go and create the PyYang tree and then, click through the model and see where it can be, and that is not very efficient. the more efficient way would be to search through all the paths, and that is what Path Browser can do for you. So right now I'm looking at the path list of the srlinux model, and I'm wondering how do I access the version string that srlinux has. So what I do is that I paste here the version string. That's the search term that I'm after. Okay, so here you see we have now filtered through the thousands of lines of paths that the srlinux model has to something which is much more easily browsable. We have now 28 entries. So this means that across all the paths, we have 28 paths that contain version search term inside of them. And you see that the Path Browser highlighted for you the version search term in each of those entries. Now, what you can do is that you can simply browse with your naked eye through this search output and see which path actually is something that relates to the version. But you can also see that every path has a prefix in the path string. Now, why do we have that? The reason is that srlinux-yang models are comprised very much the same as OpenConfig models, where you have not a single module, but you have a set of modules which are imported in different parts of the model. Some modules are augmenting the other ones, and to avoid the naming clash, you use the prefixes that modules are defined with. So here we see that the srl_nokia-if is the prefix for the interface module, and then when the prefix changes, we see the new prefix will appear along the way. And that is fine when you work with a small set of search term output. But now we have 28 lines, and these prefixes make lines a bit long. So what you can do, you can click here, hide prefixes, and the Path Browser will get rid of those. Now it is much more easier to browse the outputs, and you can see that this kind of search entries are not something that you are after. They are for network instance, IGMP, interface version. This is not the platform version. But when you scroll all the way to the bottom, you see the last string is actually, it looks pretty much the way you would expect it to. It's system information version. So what you can do right now, you can just copy it and go back to your GNMI CLI tool, and I have prepared the flags to talk to my srlinux container that I have running, and I will just paste this path here. Now if I click enter, boom, we do have the version number returned, which is great. We now know that in order to know the version of the srlinux, please use the path system information version. Okay, cool. What if you want to know how do you get access to VLANs on the interface? Again, you can type interface here, you can type VLAN afterwards, and Path Browser will search and output only the paths that have both interface and VLAN search terms inside of them. Now you can see that if you use interface, then the name of the interface, you can have the VLAN tagging leaf, which is a Boolean type, which basically answers the question if the VLAN tagging is configured on the interface. And the last example would be about the telemetry use cases. When you work with the telemetry, you typically want to know how to access some paths which contain some interesting information that I would like my telemetry application to consume. The most straightforward example is to get some counters out of the interfaces. Again, if you are familiar with NOS A, B, and C, you might not be familiar with NOS X. And if the Path Browser is here, you can efficiently and easily get to the needed leaf for your particular goal. For example, we are trying to find some statistics for the interfaces that we would like our telemetry application to consume. So what I will typically do, I will type in interface, then I would probably guess that if I want to get some traffic counters or statistics, it might be in something that has bytes in the name, right? So I use interface bytes. So what we have here, we have 6 paths. and none of them really about the statistics. So maybe it's not the right search term that I use. In SNMP you use the octets instead of bytes. So what if we do octets here? Okay, now we have 36 paths, and we can see in the middle of this page that we have interface statistics in octets, out mirror octets and out octets. Well, that sounds pretty much like it. But how do we know for sure that this is the statistics? Of course, the path kind of answers this question, but what you can also do is that you can hover over your mouse to the string of this table, and you will see the pop-up showing you the description of the leaf. This information comes straight out of Yang, so it says corresponds to, and this is the SNMP, name from the if MIP. So you can, of course, use the hover over tactic to get the description of any string that this table show you. Cool. Now, just for the sake of completeness, let's copy this string, going back to my terminal, and I will just paste it here. All right, so we got the response back with GNMI, and since I do not have any real subinterfaces or interfaces configured on this container, I have only the management interface. But since it has some data coming through it, I have some number to report back. Another thing that is quite interesting in this path browser is that you can filter through state or config leaves. This might be useful if you are trying to pre-filter your output search results to display only state or config fields. So for example, if I use like interface, name, these kind of search terms, I have a lot of paths here, and I'm not actually looking to some specific leaf, but what I can do is that I can say to path browser, please show me only state leaves. And now we have 1342 paths, but if I click state, I filter down immediately to 946. And of course, if I click on config, I will see only the config leaves for this particular search term. And then later I can, add additional search terms to the path browser, and it will already take into the account that I'm searching through the config fields. So that is how you can easily, make a distinction between config leaves, state leaves, and filter efficiently through them. So that was the path browser and the features that we incorporated into it. But of course, it's not only the path browser that we have. It is still very important to have the tree representation of the Yang model to browse through the branches and leaves and the structure that the Yang model has inside of it. So we still have the tree browser. And to access this tree browser, you click on this link here, and it will load in a second. And as you can see, this kind of resembles the PyYang output, but we just cleaned it up a bit, made it more, 20th century. And the way this tree browser works is that you still navigate through the models in the tree-like fashion. So you open the containers of leaves, whatever you have in your model, and you can go and see what sits inside of each of those elements. So the same fields that you typically see in PyYang, you will see here. For example, you have the schema, you have the type, you have flags, etc., etc. The only thing that we changed, which is not the styling, is the paths. So we removed the prefixes from the paths, making this column much shorter, and it's easier on the eyes, so you can see the same kind of condensed path that you would see in the path browser. It will also be there. And as with the path browser, you can hover over this certain leaf element or container element, and we will display the description of this particular element. This information comes from the Yang. And of course, we also had to give you the ability to take the PyYang output in a tree ASCII form. So for that, you can click on this link, and it will open you the txt file with the PyYang output as you would normally see it in your terminal. So if you are 40 plus and you like your SED, you can curl this file here and use your SED magic over it. At the same time, you can also have the paths in the same text format. If you would again like to, programmatically filter through the paths without using the web path browser, feel free to do so. All the information is here. So if you want to look at the source files of this particular Yang model 21.11.1, you click on the source and you will find the URL changed to GitHub, where we store our Yang models, and you will have the this repository checked out to a tag 21.11.1 that matches the release that you chose on the path browser. And here you will see all the Nokia modules that we have pushed to this repository, and it's a complete set of modules that srlinux uses. We also have some modules which are coming from IETF for the types and all that good stuff. So yeah, you will have all the sources if you need to. For example, if you want to generate some programmatic bindings out of those files. Now, lastly, I would like to mention that the path browser, this DIY path browser, is open source. So if you go to the SRL Labs GitHub organization, you will find the Yang browser repo here. And this repository contains all the generated paths and styling for the PyYang, and the scripts that we use to extract the models from the srlinux containers. So everything is here, right? And we will talk more about what we did specifically to make this DIY path browser, but that will be in part number 2 of this series. So if you want to know the nitty-gritty details of how we changed the old-fashioned PyYang JS3 output to a nicely looking output that we use in our path browser, please wait a bit, we will publish this video soon. We will also talk about how GNMIC was used to generate these condensed paths, and how we used the data tables to create the fast and furious path browser search capabilities. All the good stuff will be in the part 2, so yeah, subscribe and I will see you in the next one. Goodbye.